Right now, your eyes are fixed on a galaxy so immense it bends our imagination. An empire of stars racing toward us at 250,000 miles per hour. That galaxy is Andromeda, the colossal neighbor whose reach stretches far beyond what we once believed, spanning more than 220,000 light-years across the void, making the Milky Way seem almost fragile beside it. Tonight, we'll journey into the true scale of this giant, from its radiant core to the ghostly shroud of dark matter that extends far past its glowing arms. Through stellar nurseries where thousands of suns are born, across ancient clusters older than Earth itself, and through spiral arms overflowing with stars beyond counting. If you're ready to uncover the staggering immensity of our nearest galactic companion, then prepare yourself, because we're about to step into the unimaginable. Let the journey begin. Far above the sweep of our familiar sky, there hangs a pale smear of light, faint, patient, and oddly intimate. To the naked eye, it is little more than a whisper against the black, a soft oval that refuses to twinkle or blaze. Yet that gentle smear is no local cloud. It is Andromeda, a neighboring universe spelled out in the slow script of starlight, a colossal island of suns that has watched our world for millions of years. For as long as humanity has lifted its gaze, people have felt the presence of that ghostly glow. It entered myth and memory long before telescopes would reveal its true nature. The peoples of the Mediterranean folded it into stories of love and danger: the chained princess, the sea monster, the hero who cleaved the dark to save a life. Sailors and shepherds, poets and farmers, all learned to read its quiet face and find in it meaning. In China and Persia, it too was charted as a cloud among the stars, not a distant continent of suns, but a sign written across the heavens. Those ancient observers could hardly have imagined the scale that those dim photons conceal. They saw permanence, a soft smear fixed above the horizon. Science would later show that what they were tracing was motion across impossible distances. For centuries, the faint oval was a puzzle, a nebula in the language of early astronomers, a mysterious patch whose light came to us unspoiled and unassuming. Only when lenses grew sharper and instruments more daring did the fog begin to lift. By the time scientists turned their new tools on that pale patch, a revolution in thinking was already bubbling beneath the glass. Telescopes revealed structure, a flattened disk, curled arms, a bright central bulge. And then the harder question arrived. How far away was this object? It was a dispute that would change our cosmic address. For a long while, people assumed the Milky Way was the universe, and that every faint cloud belonged to its outskirts. The idea of other galaxies, whole islands of stars separated by vast oceans of space, was radical and beautiful and difficult to accept. The realization that Andromeda lay far beyond our galaxy came by measuring time and light. Astronomers found stars within that smear whose brightness pulsed with steady regularity. By reading those pulses, by using them as cosmic yardsticks, scientists could weigh distance in units of light and arrive at a startling truth. That faint oval sits millions of light years away. The photons that graze your eyes now began their voyage long before our species took its first steps. They crossed a universe where continents were still rearranging, where climates were different and creatures unfamiliar to us roamed the Earth. To look at Andromeda is to peer into the past and to watch the slow motion of cosmic history unfold. What do we mean when we say a light year? The vocabulary of everyday life fails here, so astronomers borrowed the speed of light as a measuring stick. Light races through a vacuum at roughly 299,792 kilometers per second, about 186,282 miles every single second. Stretch that motion across an entire year, and you have a distance so vast it defies ordinary intuition. Multiply that year by millions, and the separation between us and Andromeda becomes a number that belongs more to mathematics than to feeling. If one tried to bridge that gulf in a car, driving without pause at familiar highway speeds, the trip would not take centuries but billions of years. The The scale turns our private sense of time into a small chapter inside a much grander story. And yet, although the intergalactic gulf is enormous, it is not a wall. Space between galaxies is almost empty, thinly populated, fragile, and on the largest scales, gravity is the quiet cartographer shaping motion. Unlike most galaxies fleeing one another as the universe expands, Andromeda and the Milky Way are close enough and massive enough that their mutual gravity has begun to dominate. This neighbor that seems so still to our eye is creeping toward us. Measured velocities show it closing the distance at hundreds of thousands of miles per hour. It is a slow approach on human terms, but a decisive one on cosmic scales. A movement written in equations and invisible force fields. A future encounter set in motion long before any human could imagine it. Inside that faint glow are more suns than we can easily name or count. The patch we regard as a small blur is a cityscape of stars, crowded neighborhoods and empty outskirts, a place of young fire and ancient ember. Some of those suns are newborn, wrapped in the gas and dust of stellar nurseries. Others are old and steady, their light carrying the chemical record of bygone eras. Within the mosaic of Andromeda, there is a mix of ages and temperatures, a complex ecology of creation and decay that stretches across time as surely as it does across space. Each photon that finally reaches our instruments carries a story of its birth in a distant cloud, of journeys through lanes of dust, of encounters with magnetic fields, and of the gravitational nudges that altered its path. To call Andromeda visible is to understate the truth. What appears to us as a soft smear is only the southern edge of a deeper reality, the luminous face of a structure whose true breadth will only yield to persistence and patient measurement. In the epochs to come, as telescopes grow more sensitive and surveys more comprehensive, we continue to peel back layers of this neighbor, revealing streams of faint stars and ghostly arcs that tell of past violence, of encounters with smaller galaxies that left scars written in light. Even now, the soft oval that first caught ancient eyes is a threshold, inviting us to think bigger, reach farther, and humbly accept that our cosmic map is always incomplete. As instruments improved, the blurred mystery of Andromeda became less a smear and more a grand design. Through the lenses of larger observatories, astronomers traced the spiral curves that encircle its glowing core. What had seemed for centuries like a shapeless fog was revealed to be a masterpiece of architecture, arms coiled in elegant sweeps, studded with clusters of stars and veils of dust. Each improvement in resolution peeled away another layer of wonder, each exposure turning what was once myth into measured detail. In the early 20th century, Edwin Hubble turned his gaze upon this spiral and transformed our place in the cosmos forever. By studying the faint, rhythmic flickers of Cepheid variables, Hubble unlocked the distances written in their light. His calculations confirmed what some had only whispered. Andromeda was not a companion cloud inside the Milky Way, but an entirely separate galaxy, millions of light-years away. The great debate that once split astronomers, whether nebulae were inside our galaxy or beyond, was settled by the steady pulse of those stars. In that moment, the universe expanded from a single island to an archipelago of uncountable galaxies, each one a realm of suns, and Andromeda became our nearest great neighbor in a newly enlarged cosmos. This realization brought scale into sharper focus. Andromeda was not merely larger than thought, it was colossal, stretching some 220,000 light-years across, making our Milky Way feel modest by comparison. With nearly 1 trillion stars in its disk and halo, Andromeda became the yardstick by which other spirals were measured. Its sheer size redefined what was possible in galactic formation, challenging astronomers to ask how such sprawling systems assemble from the raw material of the cosmos. Look closely at its spiral arms, and you find not uniformity, but richness. Clouds of hydrogen gas weave like rivers through the disk, glowing in crimson where ultraviolet light from hot young stars ignites them. Within these nurseries, stars are born in swarms, thousands at a time, each a furnace that will burn for millions or billions of years. Against this vitality are regions of older populations where stars shine in steadier yellow and red hues, marking epochs long past. The distribution of these stellar generations tells a story of waves of creation rippling through the galaxy, a history written not in words, but in light and chemistry. Among the treasures of Andromeda are its globular clusters, tight spheres of stars bound together for billions of years. More than 400 of these ancient assemblies orbit the galaxy, each one a fossil of its earliest days. Within them lie some of the oldest stars in the universe, glowing witnesses to a time when galaxies themselves were young. These clusters orbit like satellites around a metropolis, reminders of the chaotic early universe when fragments collided and coalesced into larger structures. Andromeda's core is no less compelling. At its center lies a crowded bulge where stars are packed more densely than anywhere else in the galaxy. Here, orbits twist under the influence of gravity from billions of suns, and at the very heart lurks a supermassive black hole, a gravitational well millions of times more massive than our sun. Around it, stars whip through space at extraordinary speeds, their dance testifying to the hidden presence of this dark anchor. Unlike the stillness we imagine at the galactic core, this is a region of frenzy and compression, a cauldron where the laws of physics press matter to its extremes. Dust lanes, too, carve through Andromeda's disk, obscuring light with their mottled shadows. Yet far from being obstacles, these rivers of dust are the raw ingredients of creation. They are the ash and smoke of previous generations of stars, recycled into the birth of new suns and planets. To trace their paths is to see the galaxy as an organism in motion, consuming and renewing itself through the endless cycles of stellar death and rebirth. And beyond all this lies the halo, the faint, ghostly sphere surrounding Andromeda that extends far beyond the visible arms. Here, the density of stars thins, but the story does not end. Streams of faint light arc through this space, remnants of smaller galaxies torn apart and absorbed by Andromeda's gravity. These tidal streams are scars of past encounters, evidence of cannibalism on a galactic scale. Each one is a testimony that galaxies grow not gently, but by consuming their neighbors. Andromeda, for all its beauty, is no exception. It is both a creator of light and a devourer of worlds. Our instruments can now map these features in exquisite detail, yet each discovery raises more questions. How many stars truly lie within its disk and halo? How much dark matter surrounds it, unseen yet essential to its stability? How has its history of collisions shaped the spiral we see today? Every measurement is a new doorway into understanding, and a reminder that Andromeda is both our neighbor and a mystery still unfolding. Beneath the beauty of Andromeda's spiral arms and glowing core lies a presence that cannot be seen. It is not starlight, nor dust, nor gas, but something more elusive, more fundamental. The galaxy, immense though it appears, is only the tip of an iceberg. Surrounding it is a halo of invisible matter, a cloak of mass that outstretches the visible disk many times over. This is dark matter, the silent architecture of the universe. Astronomers first sensed its presence not by direct observation, but by its gravitational whisper. When they measured the speeds of stars rotating around Andromeda's disk, they found an enigma. The outer stars circled far faster than visible matter alone could explain. According to Newton's laws, those stars should have drifted away, flung into the void. Instead, they clung tightly to the galaxy, held in place by an unseen hand. That hand is dark matter, outweighing the galaxy's visible components by a staggering factor. This halo is vast, stretching out perhaps 2 million light-years, overlapping with the halo of our own Milky Way. It means that long before the visible spirals collide, their dark matter envelopes have already begun to mingle, an invisible prelude to the drama still to come. The two galaxies are connected not only by gravity, but by the invisible filaments of the cosmic web, strands of dark matter that weave galaxies into clusters and clusters into superclusters. Andromeda is not an isolated jewel, but a bead strung upon that immense lattice of mass and void. Dark matter does not glow, reflect, or interact with light. It passes through stars and planets as though they were not there. Yet without it, galaxies like Andromeda could not exist. Its gravity sculpts the disk, steadies the arms, and provides the scaffolding upon which visible matter accumulates. Without this invisible skeleton, Andromeda's stars would drift apart like leaves in the wind. Dark matter is the hidden glue of the cosmos, the silent sculptor that shapes galaxies from the earliest ages. Modern telescopes and simulations allow astronomers to trace this hidden structure. By watching the motions of stars at the galaxy's outskirts, by mapping the faint arcs of stellar streams, researchers infer the halo's vast reach. Supercomputers, armed with the laws of physics, simulate billions of particles of dark matter to recreate the shape of galaxies. These simulations reveal halos not as smooth spheres, but as intricate, clumpy, dynamic realms, shaped by collisions, mergers, and tidal forces over billions of years. And Andromeda, like every great galaxy, carries these scars of a violent past. In the halo, faint dwarf galaxies orbit as satellites, caught like moths in a vast gravitational lantern. Some are intact, small spirals and spheroids whose stars move in quiet harmony. Others are torn apart, their material smeared into streams that lace across the halo. These remnants are fossils of Andromeda's history of conquest, whispers of smaller galaxies consumed in its long hunger for growth. By studying them, astronomers reconstruct Andromeda's lineage, tracing how 1 trillion stars assembled from countless smaller fragments. But the halo holds more than just dwarfs and debris. It also carries the echoes of the intergalactic medium, the faint gas that threads the cosmic web. Observations of quasars shining behind Andromeda reveal absorption lines etched into their light, the fingerprints of hydrogen gas in the halo. This reservoir of gas is vast, stretching far beyond the visible spiral, and may serve as the raw material for future generations of stars. The halo, invisible to the eye, is not empty. It is a reservoir, a battlefield, a memory of everything the galaxy has touched. What makes dark matter even more mysterious is its nature. We do not yet know what it is. It is not ordinary atoms, nor photons, nor neutrinos. It does not radiate, does not collide, does not shine. It reveals itself only through gravity, bending the paths of stars and light. Some imagine exotic particles beyond the standard model of physics. Others wonder if our very understanding of gravity itself is incomplete. The answer remains hidden, but Andromeda's motions whisper that something massive and unseen is there, shaping everything we observe. And so, when you gaze at the faint oval in the sky, you are not merely seeing stars. You are glimpsing the surface of a vast, invisible world, a gravitational empire extending millions of light years in every direction. The spiral arms and the glowing core are just the lantern's flame. The dark matter halo is the lantern itself, holding the galaxy together, guiding its past, and scripting its future. Understanding Andromeda's dark halo is more than curiosity. It connects to the fate of our own galaxy, for the Milky Way too wears such a cloak. The overlap of these halos means the two galaxies are already engaged in a cosmic embrace, drawn closer, not by chance, but by the inevitability of gravity, written across scales larger than imagination. Their visible collision lies billions, lions of years ahead. But in the unseen world of dark matter, that collision has already begun. Inside Andromeda's luminous arms, the quiet glow of stars is only half the story. The true heartbeat of the galaxy lies in the regions where stars are born, vast clouds of gas and dust sprawling across hundreds of light years. These are the stellar nurseries, the forges where hydrogen collapses under gravity to ignite into suns. Seen through powerful telescopes, they appear as glowing nebulae, painted in crimson and violet, as if the galaxy itself were breathing fire into the void. Within these cradles, gravity works with delicate patience. Wisps of hydrogen and helium, remnants of the early universe enriched by heavier elements from past generations of stars, gather and swirl. Over time, these clouds fragment into knots, and each knot contracts, heating until nuclear fusion ignites. A new star is born, and with it, the possibility of planets, moons, and perhaps even life. In Andromeda, these nurseries blaze by the thousands, entire regions where young blue stars cluster so tightly they outshine their surroundings. Their ultraviolet light ionizes the gas, causing it to glow and betray their hidden presence to our eyes. But creation is never gentle. Massive stars, though brilliant, burn their fuel quickly. Within a few million years, a blink of cosmic time, they explode as supernovae, hurling shockwaves that ripple through their neighborhoods. These blasts compress nearby gas clouds, triggering more star birth even as they scatter heavy elements across space. The cycle is self-perpetuating, destruction feeding creation, endings seeding beginnings. And so the arms of Andromeda shine not with a static light, but with a living pulse, a rhythm of birth and death echoing across millions of years. Threaded through this brilliance are the dust lanes, dark streaks that coil through the spiral arms like rivers of shadow. To the naked eye they obscure, swallowing starlight and leaving patches of emptiness. Yet in truth, these dust lanes are rich reservoirs of potential, the ashes of old stars that will one day form new generations, microscopic grains of carbon and silicates, forged in the deaths of ancient suns, now drift as the raw material for planets and moons, yet unformed. Dust is memory and promise, and in Andromeda's lanes, it writes the story of renewal. Scattered beyond the disk lie the ancient guardians of the galaxy, the globular clusters. These are dense, spherical assemblies of stars, each holding tens of thousands, sometimes hundreds of thousands of suns bound tightly together. They orbit Andromeda like relics, fossils from the dawn of its history. Some are older than our own solar system, dating back more than 10 billion years. To peer into one of these clusters is to look across time, into a realm where stars glow with a steady, ancient light, unchanged since the first galaxies took shape. Each globular cluster tells a story of survival. Born in the chaotic youth of Andromeda, when galaxies collided and merged more frequently, these clusters endured tidal forces that would have torn lesser systems apart. Their stars are generally low in heavy elements, revealing that they formed before the cosmos had been enriched by many generations of supernovae. They are the grandparents of the galactic family, still orbiting faithfully after billions of years, silent witnesses to Andromeda's long journey through time. Between these clusters and the spiral arms, stars of every age populate the galaxy. Young, hot, blue stars blaze with intensity, marking the sites of recent creation. Middle-aged stars like our Sun burn steadily, maintaining habitable zones where light and Phi might someday emerge. Older red giants swell and fade, shedding their outer layers back into the interstellar medium, enriching the galaxy with carbon, oxygen, and iron. The cycle of life and death continues endlessly, weaving Andromeda into a tapestry where every point of light is both an individual and part of a collective symphony. Amid this cycle of birth and renewal, not all is serene. Some stars travel in isolation, thrown from their homes by gravitational encounters or supernova explosions. These rogue stars wander the galaxy, carrying with them the memory of their origins. Others exist in pairs or trios, bound together in delicate gravitational dances. In dense clusters, these dances can become chaotic, with stars exchanging partners or colliding in brilliant flares of energy. Andromeda is not a quiet, static painting, but a restless, living entity, its stars in constant motion. When we trace this galactic ecosystem as a whole, a picture emerges of balance and continuity. The spiral arms are nurseries, the core is a furnace, the halo is a graveyard, and the clusters are ancient libraries of stellar memory. Every part plays its role in maintaining the grandeur of the whole, and while we may see it only as a faint smear in our night sky, within Andromeda, the drama of existence unfolds on a scale beyond imagination, reminding us that even the most ordinary patch of starlight conceals worlds of complexity. At the very center of Andromeda, beyond the spiral arms, beyond the glowing bulge of billions of stars, lies a place of unimaginable power. It is not a star, nor a cluster, nor a nebula, but a well in space-time itself, a supermassive black hole weighing perhaps 100 million times more than our Sun. Invisible by its nature, it reveals itself through its influence, pulling stars into orbits so tight and fast that they streak around the core at thousands of kilometers per second. Here, the normal rules of the universe bend and twist under the gravity of a single, colossal presence. Astronomers first suspected this dark titan through the unusual motions of stars near Andromeda's nucleus. Observations showed that something immensely heavy resided in a space no larger than our solar system. Only a black hole could explain such density. Around it swirls a maelstrom of matter, gas heated to extreme temperatures, emitting X-rays as it spirals inward. Occasionally, this material falls past the event horizon, vanishing into silence while releasing flashes of radiation that ripple across the galaxy. Though quiet compared to the raging hearts of active galaxies, Andromeda's central black hole remains a sleeping giant, its hunger subdued but never extinguished. This is not the only grave marker within Andromeda. Scattered across its disk are countless stellar mass black holes, remnants of massive stars that burned through their fuel and collapsed under their own weight. Each is the ghost of a giant, now invisible, detectable only when it feeds upon a companion star. These smaller black holes dot the spiral like embers of forgotten fires, silent but potent, reminders that even stars can end in darkness. Alongside them are neutron stars, the ultra-dense remnants of supernova explosions. Imagine the mass of a sun compressed into a sphere no larger than a city, where atoms, the epochs, themselves collapse and matter exists as neutrons packed shoulder to shoulder. In Andromeda, these neutron stars spin rapidly, some flashing like lighthouses as pulsars, their beams sweeping across space with clock-like precision. They are the metronomes of the galaxy, ticking off cosmic time in pulses of radio waves and X-rays. Together, these remnants paint a portrait of Andromeda as both a cradle and a graveyard. For every nursery where new stars ignite, there is a black hole or neutron star marking the end of another life. The galaxy is not static but cyclical, every generation of stars feeding the next, recycling material through explosions, collapses, and accretion. And at the center, the supermassive black hole sits as the ultimate arbiter, a gravitational monarch around which the entire galaxy turns. The core itself is crowded beyond imagination. Stars here are packed thousands of times more densely than in our local neighborhood of the Milky Way. In such an environment, encounters between stars are common. Binary systems are torn apart, new partnerships forged, and sometimes collisions ignite cataclysmic outbursts of energy. Gravity weaves a constant drama in these central regions, every orbit a balancing act between motion and collapse. Even as the core seethes with hidden violence, it radiates beauty. The bulge glows golden in visible light, the collective brilliance of ancient stars that have burned for billions of years. Their light has crossed the gulf of space, carrying with it the chemistry of epochs long past. Some of these stars may be survivors of mergers, their orbits warped by encounters with other galaxies. Others may be the quiet descendants of the galaxy's earliest generations, their age rivaling that of the universe itself. Together, they form a population that binds the core with the weight of time. Modern instruments have allowed us to peer deeper into this nucleus. Infrared telescopes cut through dust, revealing structures once hidden. Radio observatories capture emissions from gas spiraling around the central black hole. X-ray telescopes detect bursts of energy when matter is devoured. Each wavelength uncovers a different face of Andromeda's heart, showing us that it is not a single feature, but a complex ecosystem of forces, radiation, gravity, magnetic fields, all interacting at the edge of physics itself. And yet, for all our progress, mysteries remain. How did this black hole grow so massive? Was it born large, or did it feed for billions of years on surrounding gas and stars? Does it flare violently in cycles, only to retreat into dormancy? And how does it shape the broader galaxy around it, regulating star formation, carving pathways for matter, influencing the very rhythm of Andromeda's evolution? These are questions that scientists still wrestle with, questions that point not only to Andromeda, but to the nature of every galaxy across the cosmos. When we look toward that faint oval in the sky, we are not only seeing stars. We are glimpsing the shadows of collapsed suns, the pulses of neutron stars, the hidden hand of countless black holes, and at the very heart, a supermassive presence whose gravity anchors a trillion suns. It is a reminder that even the most beautiful spirals in the heavens are built upon extremes, upon violence, collapse, and forces that challenge our very understanding of nature. Beyond the glowing disk of Andromeda, scattered like sparks around a bonfire, orbit dozens of dwarf galaxies. They are small companions, far less luminous than their colossal host, yet vital to its story. Some are faint smudges of stars, barely distinguishable from the background of space. Others are compact spheroids or irregular clumps shaped by gravity and stripped by tidal forces. Together, they form a retinue, a family of satellites bound to Andromeda's immense gravitational embrace. Among the brightest of these companions is Messier 32, a tiny elliptical galaxy tucked close to Andromeda's disk. Though modest in size, it carries scars of a turbulent past. Its outer layers appear to have been torn away by Andromeda's pull, leaving behind a compact core of tightly packed stars. Another neighbor, Messier 110, drifts just beyond, a dwarf elliptical with hints of star formation still smoldering within. Around them swirl dozens more faint satellites, so dim that only modern surveys with sensitive detectors can trace their light. Each is unique, each a survivor of encounters with their giant host. But these dwarfs are more than ornaments. They are fuel. Galaxies grow not only by forming stars within, but by consuming their companions. Astronomers have discovered faint stellar streams arcing around Andromeda, like ghostly rivers of light. These streams are the shredded remains of galaxies that strayed too close, stretched and torn apart by tidal forces until their stars became part of Andromeda's halo. What looks serene from afar is in truth a battlefield, a record of countless acts of cannibalism written across the night. The evidence is overwhelming. Observations show that Andromeda's halo is filled with debris, arcs, loops, and clumps of stars that once belonged to smaller systems. Each stream tells a story of a merger, of a dwarf galaxy swallowed whole, its structure erased, its identity dissolved. Over billions of years, this process has fed Andromeda, allowing it to amass nearly 1 trillion stars. Without this steady diet of companions, it would never have grown to rival or surpass the Milky Way. This cosmic cannibalism is not unique to Andromeda. It is the way of galaxies, the fundamental process by which the universe builds its grandest structures. Our own Milky Way, too, has consumed smaller galaxies and even now is tearing apart the Sagittarius dwarf. But Andromeda's scale makes its feasts more dramatic, its streams more visible, its history easier to read. It stands as a natural laboratory for understanding how galaxies evolve through collision and assimilation. Consider what happens to a dwarf galaxy as it falls toward Andromeda. At first, it orbits quietly, tracing graceful ellipses through the halo. But as it spirals closer, gravity exerts unequal pulls across its structure. The side facing Andromeda feels a stronger tug than the far side, and slowly, the dwarf begins to stretch. Stars are pulled into long tails, gas is siphoned away, and over time, the satellite unravels. What was once a coherent galaxy becomes a trail of debris, its stars scattered into Andromeda's halo, indistinguishable from native populations. In this way, the giants of the cosmos grow at the expense of their smaller kin. Some of these mergers are ancient, their streams now faint whispers, barely detectable against the cosmic background. Others are fresh, their arcs sharp and bright, evidence of recent encounters still unfolding. Computer simulations, fed with these observations, recreate Andromeda's violent past, showing how it grew through dozens, perhaps hundreds, of such mergers. The galaxy we see today is not a static entity, but the sum of every collision, every feast, every act of cosmic assimilation across billions of years. Yet within this violence lies creation. Each merger stirs the gas within Andromeda, triggering waves of star formation. When galaxies collide, their gas clouds compress, igniting bursts of newborn stars. These starbursts can light up the galaxy, outshine everything around them for millions of years. Cannibalism is not only destruction, it is also renewal, a cycle that enriches the galaxy with fresh generations of stars and fresh waves of light. In this way, Andromeda is both predator and nurturer, a cosmic paradox that consumes to create. Even the dwarf companions that survive tell part of this story. Their motions around Andromeda, mapped with painstaking precision, reveal the pull of the galaxy's dark matter halo. They act as tracers, tiny marbles moving in the current of an invisible ocean, allowing astronomers to map the unseen mass around their host. Thus, even in their diminutive size, these dwarfs serve a purpose larger than themselves, helping us understand the skeleton of the cosmos. To stand under the night sky and look toward that faint smear of light is to see not only a galaxy, but a history of conquest. It is to witness the aftermath of collisions so vast they defy human imagination. Wars fought not in days or years, but across eons. Andromeda is what it is because it has consumed others. Its majesty is built upon the sacrifice of smaller worlds, its brilliance upon the erasure of rivals. And still, the process continues, each dwarf galaxy orbiting today a potential feast of tomorrow. For all its beauty and distance, Andromeda is not a permanent neighbor fixed in place. It is moving, hurtling toward us across the void at more than 250,000 miles per hour. This approach is not subtle speculation, but measured fact, confirmed by the Doppler shift of its light. Unlike most galaxies, which recede as the universe expands, Andromeda defies that tide. Its gravity and ours are locked together, drawing us into a slow, inevitable embrace. The night sky, so still to human eyes, hides a grand convergence already in motion. The timeline is vast. In about 4 billion years, Andromeda and the Milky Way will meet. To imagine such a collision is to stretch beyond ordinary intuition. Galaxies are not solid objects, but vast, diffuse systems. Stars within them are so far apart that the chance of two colliding directly is vanishingly small. Yet gravity will weave their motions into new patterns, reshaping both galaxies into something entirely new. What we know as the Milky Way and Andromeda will be erased, reborn as a single, merged system. Simulations give us glimpses of this future. At first, the galaxies will pass through each other, their spiral arms distorted into long tidal tails, flung out like ribbons of starlight. The central black holes will circle, drawn closer by friction within their surrounding gas and stars. Over time, their orbits will decay until they merge into a single, supermassive entity, releasing gravitational waves that ripple across the cosmos. The stars of both galaxies will settle into new orbits, forming an elliptical galaxy, massive, luminous, and serene compared to the spirals from which it was born. Astronomers have named this future creation Milkomeda, a cosmic hybrid, the destiny of both our galaxy and Andromeda. It will shine brighter than either of its parents, a giant elliptical glowing with the combined light of 2 trillion stars. Our solar system, carried along by this tide, may be flung into a more distant orbit, cast toward the outskirts of the new galaxy. Or perhaps it will find itself drawn closer to the core, where stars whirl in crowded dances around a black hole far larger than the one that anchors our Milky Way today. The details are uncertain, but the inevitability of merger is written clearly in the math of gravity. From Earth, if any human descendants remain to witness it, the sky will transform into a spectacle unlike any seen before. Over millions of years, Andromeda will swell in the heavens, its spiral arms stretching across the night like luminous rivers. Eventually, the two galaxies will merge visually as well, filling the firmament with streams of stars so vast and bright that constellations will vanish, replaced by a sky ablaze with the patterns of galactic collision. It will be both breathtaking and humbling, a reminder that the night sky itself is not fixed but evolving. Yet for all its drama, this collision will not mean destruction for most stars and planets. The spaces between them are simply too vast. Instead, the violence will unfold in subtler ways. Gas clouds colliding and compressing, igniting waves of star formation. Dwarf galaxies pulled into the fray. Long tidal streams painting the new galaxy with arcs of light. It will be less a shattering impact than a slow, intricate dance. Chaotic, yes, but also profoundly creative. The legacy of Milkomeda will endure for billions of years after. With no nearby giant galaxies left to collide with, the merged system will drift in relative solitude, slowly reddening as its supply of gas is consumed and star formation fades. In time, it will become a graveyard of aging stars, glowing dimmer against the expanding void of the cosmos. The cycle of birth and merger that created it will quiet, leaving behind a single colossus adrift in darkening space. This fate is not unique to us. Across the universe, galaxies collide and merge constantly. their structures shaped by encounters as surely as by their own internal forces. The future of the Milky Way and Andromeda is simply one chapter in this universal story, a reminder that even the grandest structures we see are not eternal, but part of an unfolding drama of change. To live at a time when we can predict this future is to glimpse not only our origins, but our destiny, written in the language of gravity and light. And so, when we gaze at that faint smear of light in the night sky, we are not only seeing a galaxy as it is, we are seeing a partner on a collision course, a mirror of our own Milky Way, destined to merge into something larger. The story of Andromeda is not only about what it has been, a devourer of dwarfs, a giant among giants, but what it will become, half of a new creation, the next chapter in the life of the cosmos itself. To speak of Andromeda is to speak of scale beyond comprehension. 1 trillion stars, hundreds of thousands of light years across, wrapped in a halo of dark matter stretching millions of light years more, all of it drifting toward us across the silent gulf. Numbers lose meaning here. They outgrow the frameworks of human thought, forcing us into metaphors, comparisons, and awe. Andromeda is not merely an object in the sky, it is a reminder of the immensity of everything we inhabit. When ancient eyes first traced its glow, they saw a myth, a princess chained, a hero triumphant. When telescopes turned upon it centuries later, they saw a nebula, a puzzle at the edge of knowledge. And today, we see it for what it is. A galaxy, vast and real, our closest companion in the endless expanse. Each age has redefined it according to its tools and imagination, and yet the galaxy itself has not changed. Only our perspective has grown, our questions sharpened, our humility deepened. Within Andromeda lie the full cycles of creation and destruction. Stars ignite and die. Gas clouds collapse and disperse. Black holes lurk unseen. Neutron stars spin their cosmic clocks, and ancient clusters trace the galaxy's earliest memories. It is at once a nursery, a graveyard, and a city of light, its neighborhoods alive with forces both gentle and violent. To describe it is to describe a microcosm of the universe itself, a single galaxy containing every chapter of cosmic story in miniature. And yet, Andromeda is not unique. It is one among trillions of galaxies that fill the observable universe, each with its own stories of birth, merger, and death. That faint smear in our sky is both extraordinary and ordinary, a neighbor close enough to touch our imagination but distant enough to remind us of the vastness still beyond. To look at it is to grasp a paradox, that we are part of something inconceivably immense, and yet our place within it is vanishingly small. The future it shares with the Milky Way only deepens this reflection. The merger to come is not an anomaly, but a destiny shaped by gravity itself. It reminds us that even galaxies, those seemingly eternal beacons, are transient forms, destined to transform into something else. The cosmos is not static, but alive, its structures constantly evolving. Our skies will change, our constellations will fade, and our galaxy will be folded into something new. The night itself is temporary, a canvas ever in motion. And what of us, tiny creatures orbiting an ordinary star in one corner of this unfolding drama? For all our smallness, we are witnesses. We have built tools that allow us to measure distances across millions of light years, to trace the pulses of ancient stars, to infer the existence of matter we cannot see. We have pieced together stories that span billions of years, stories written in the faintest photons and the subtlest motions of distant suns. Against all odds, life on this small world has learned to read the universe, and in reading it, to see itself more clearly. Andromeda, then, is not just an object of study. It is a teacher. It shows us that beauty can be immense, that creation is inseparable from destruction, that nothing in the cosmos is permanent, and that humility is the most natural response to reality. To look upon it is to feel the weight of time, the scale of sea, pace, and the fragile brilliance of our own existence. It invites us to wonder not only about galaxies, but about ourselves, our place, our future, and our role in a universe that will go on long after we are gone. So the next time you stand beneath the night sky, lift your gaze to the faint oval glow in the constellation of Andromeda. Know that you are looking across millions of years into a galaxy as vast and complex as our own. Know that it is moving, that its fate is tied to ours, that in billions of years its stars will mingle with ours in a new creation. And let that knowledge fill you not with fear, but with awe. Awe at the scale of the universe, awe at the brief gift of consciousness that allows us to see it, and awe at the fact that even from this tiny planet, we can trace the outlines of eternity. Every galaxy is a book written in the language of starlight, and Andromeda's pages are among the richest we can read. Each star carries within it the chemical memory of the universe at the time of its birth. To study Andromeda's stellar populations is to trace a timeline stretching back nearly to the dawn of galaxies themselves. Astronomers divide its stars into broad groups called stellar populations. The oldest belong to population 2. Stars formed in the early universe when hydrogen and helium dominated and heavier elements were scarce. These stars glow red and dim, with low metallicity, their light telling us they were forged before supernovae seeded the cosmos with richer materials. Many of these ancient suns inhabit the halo and globular clusters, orbiting like elder sentinels around the galaxy's disk. Closer to the spiral arms, we find younger stars, the population 1 generation. These stars sparkle blue and white, their spectra marked with heavier elements like carbon, oxygen, iron, and silicon. The ashes of earlier stars recycled into new life. Their presence means that Andromeda has been through countless cycles of star birth and death, each one enriching the galactic medium a little more. In their atmospheres, we can read the signatures of supernovae long past, the fingerprints of explosive events that spread the raw ingredients for planets and, perhaps, for life. This chemical evolution is no accident, but the product of billions of years of stellar alchemy. A star begins with hydrogen, fusing it into helium. In massive stars, fusion forges carbon, oxygen, and heavier elements all the way up to iron. When such stars explode as supernovae, they scatter these materials into the galaxy, seeding clouds of gas and dust. The next generation of stars forms from this enriched matter, inheriting higher metallicities. Thus, with each cycle, Andromeda grows chemically richer, its stars more complex, its potential for habitable worlds greater. The distribution of these populations paints a map of Andromeda's history. The halo stars, ancient and metal-poor, remind us of its early youth, a time when the universe itself was still sparse and primitive. The bulge stars, older than those in the disk, but younger than the halo, speak of the galaxy's formative mergers. The disk stars, with their spiral patterns and higher metallicity, tell of steady creation over billions of years. Together, they reveal a layered history, one that cannot be captured in a single moment, but only in the cumulative memory of countless suns. Among the most fascinating are the variable stars, whose pulsations allow us to measure distance and age with precision. Cepheids, in particular, have been crucial in charting Andromeda's place in the universe. Their rhythms act like cosmic clocks, revealing not only how far the galaxy lies, but how its stars evolve. Each flicker, each pulse, is a whisper from a distant past, carrying both science and poetry across the void. Chemical mapping has also revealed gradients across Andromeda. Its core stars are generally older and more metal-rich, a sign of intense early star formation where material was recycled quickly. The outer regions, by contrast, are more metal-poor, suggesting slower enrichment and the accretion of smaller, less developed galaxies. These gradients confirm what tidal streams and simulations suggest. Andromeda has grown through both internal processes and external feasts, knitting together stars of many origins into a single, majestic spiral. This chemical richness raises profound questions. If Andromeda holds 1 trillion stars, how many planets might circle them? And if those planets form from enriched material containing carbon, oxygen, and iron, how many might be rocky, Earth-like worlds? We cannot yet know, but the odds are staggering. Statistically, there could be billions of planets in Andromeda, some with conditions suitable for life. When we study its starlight, we are not only reading the history of a galaxy, but glimpsing the possibility of countless unseen worlds. To explore Andromeda's chemical evolution is to see the universe as an artist layering colors onto a canvas. The first brushstrokes were simple, just hydrogen and helium. Then came splashes of heavier hues: carbon from one star, oxygen from another, iron from a supernova's blast. Over billions of years, the palette has grown richer, and today Andromeda's stars shine with the full spectrum of cosmic history. It is a reminder that galaxies are not static objects, but evolving artworks, painted by the cycles of creation and destruction that define the cosmos. And so, within the faint oval of light we glimpse from Earth, there lies a vast library of stellar chemistry. Each star is a page, each element a word, each cluster a chapter. Together, they tell a story of growth, complexity, and possibility. A story not just of Andromeda, but of the universe itself. Though immense in its own right, Andromeda does not drift through the universe alone. It belongs to a small community of galaxies bound together by gravity, a gathering known as the local group. This cluster, though modest compared to sprawling galaxy clusters like Virgo or Coma, is our immediate cosmic neighborhood, a stage upon which Andromeda plays the starring role. The local group spans about 10 million light-years across and contains more than 70 galaxies, most of them dwarfs. Yet two giants dominate its landscape: the Milky Way and Andromeda. Between them lies a balance of power, each with a mass of more than 1 trillion suns, each surrounded by halos of dark matter that overlap like vast invisible oceans. Their mutual attraction is the force shaping the group's destiny, pulling them together in a slow but inevitable embrace. The Triangulum Galaxy, M33, is the third largest member of this community, a spiral far smaller than its companions, yet bright enough to see with modest telescopes. It, too, may be gravitationally bound to Andromeda, orbiting as a distant companion. Observations suggest that Triangulum has likely interacted with Andromeda in the past, and may again play a role in the coming merger with the Milky Way. Its streams of gas and stars hint at a history of encounters, threads in the larger tapestry woven by gravity's hand. Around these three great spirals swarm dozens of dwarfs, faint spheroidal galaxies, irregular clumps of stars, and satellite systems scattered like embers. Some, like the large and small Magellanic Clouds, orbit the Milky Way. Others cling to Andromeda's halo, faint companions that mark its gravitational reach. Together they form a retinue, smaller players in a drama defined by the gravity of giants. Andromeda's influence within the local group is immense. Its tidal forces shape the orbits of satellites, tugging them into streams and arcs. Its sheer mass anchors one side of the group's balance, countering the pull of the Milky Way. The space between the two giants is not empty, but filled with faint dwarfs drifting in tenuous orbits, uncertain of their allegiance. Some belong to Andromeda, some to the Milky Way, and some hover in the liminal zone between, claimed by neither but influenced by both. The local group itself drifts through space as part of something even larger, the Laniakea supercluster, a sprawling structure containing hundreds of thousands of galaxies. Within this vast hierarchy, Andromeda is at once significant and small, a titan within its local neighborhood, yet only one jewel in a necklace of incomprehensible length. Its membership in the local group reminds us that galaxies, like stars, rarely exist in isolation. They are social structures, bound by invisible threads of gravity, interacting across scales far greater than their individual sizes. Studying Andromeda's role in this network has given astronomers profound insights. By mapping the motions of its satellites, scientists have constrained the mass of its dark halo. By observing its relationship with Triangulum, they have glimpsed the dynamics of galaxy interactions in miniature. By comparing it with the Milky Way, they have built models of how two giants might evolve when placed side by side, feeding and shaping one another across billions of years. The local group also offers perspective. To us, Andromeda appears vast beyond measure. Yet in that sense, a company of the cosmos, it is simply one member of a modest family. Larger clusters exist where thousands of galaxies crowd together, their collisions more frequent, their interactions more violent. Against such backdrops, the local group is quiet, almost pastoral, its drama stretched across longer timescales. And yet for us, it is home. It is the community in which our galaxy was born, evolved, and will ultimately merge into something new. When we speak of Andromeda as our neighbor, we do not mean it casually. It is the nearest spiral of true scale, the companion that defines the boundaries of our gravitational domain. Its relationship with the Milky Way is not just a curiosity, but the engine that drives the local group's fate. In billions of years, when the two collide, the local group will be reshaped. The dwarfs will be drawn into the fray, Triangulum may be cast into new orbits, and a new giant galaxy will emerge, dominating the neighborhood for eons to come. Thus, Andromeda's role is both local and cosmic. It is at once a neighbor across 2 million light-years and a titan shaping the destiny of an entire group of galaxies. To understand it is to understand not only one galaxy, but the dynamics of our own celestial community. And in that understanding lies a humbling truth, that even at the scale of galaxies, nothing exists alone. Every star, every system, every giant spiral is part of a larger whole, bound together in a cosmic web that stretches across the universe. The story of Andromeda is not only written in stars, but also in the instruments we have built to study it. Every leap in technology has pulled back another layer of mystery, each new lens and mirror turning a faint blur into a sprawling realm of discovery. The galaxy itself has not changed, but our eyes have grown sharper, our reach farther, our imagination wider. The earliest telescopes revealed Andromeda as something more than a smudge. In the 17th century, observers like Simon Marius and Giovanni Battista Hodierna sketched its faint glow, recording what the naked eye could only guess at. They called it a nebula, a cloud among the stars, unsure whether it was local or distant. For centuries, it remained in this category, one of many fuzzy patches catalogued by astronomers, its true nature hidden by distance and assumption. In the 18th century, Charles Messier compiled his famous catalogue of nebulous objects, a guide meant to help comet hunters avoid confusion. Andromeda earned its place as Messier 31, one of the brightest and most prominent entries. To Messier, it was still just a curiosity, an object to be noted but not yet understood. William Herschel, with larger telescopes, studied its structure more closely, noting its elongated shape and central brightness. But even he could not pierce the veil of its distance. The universe was still thought to be bounded by the Milky Way, and Andromeda was assumed to lie within its confines. The true breakthrough came in the early 20th century with the work of Edwin Hubble. Using the powerful 100-inch Hooker telescope at Mount Wilson Observatory, Hubble identified Cepheid variable stars within Andromeda. These stars, with their predictable pulsations, acted as cosmic yardsticks, allowing him to measure the galaxy's distance. The result was revolutionary. Andromeda lay well outside the Milky Way, more than 2 million light-years away. In that moment, the universe expanded. What had once been thought of as the entirety of creation, our galaxy, became just one island among many. Andromeda was no longer a nebula, but a galaxy in its own right, and Hubble's discovery forever changed our place in the cosmos. Since then, Andromeda has become a laboratory for astronomy. Telescopes across the globe and in orbit have turned their gaze upon it, probing its stars, clusters, and streams. The Hubble Space Telescope, launched in 1990, provided some of the sharpest views ever captured. Its panchromatic Hubble Andromeda Treasury (PHAT) survey imaged a vast swath of the galaxy in unprecedented detail, cataloging hundreds of millions of stars. Each pinpoint of light became a data point, allowing astronomers to study stellar evolution on a galactic scale. Infrared observatories like Spitzer have peered through dust lanes to reveal hidden nurseries of star formation. X-ray telescopes such as Chandra have detected the energetic remnants of supernovae and the accretion disks around black holes. Radio arrays have traced the cold hydrogen gas that outlines Andromeda's spiral arms, mapping the raw material from which future stars will form. Across the electromagnetic spectrum, Andromeda has been dissected, each wavelength telling a different chapter of its story. And now, a new era begins with the James Webb Space Telescope, JWST. Its infrared eyes, sharper than any before, allow us to probe deeper into Andromeda's dusty regions to witness the formation of stars and planetary systems with unprecedented clarity. JWST is not only extending our reach, but refining our understanding, showing us details of Andromeda's chemical composition, its star clusters, and its faint outer halo. With each image, the galaxy becomes less a blur and more a living system, its complexity laid bare by technology that seemed impossible only decades ago. Even ground-based telescopes have entered a golden age. The upcoming Extremely Large Telescope, ELT, in Chile, and the 30-meter telescope, TMT, promise to resolve individual stars in Andromeda's outer regions, mapping them in detail once thought impossible. These giants, paired with adaptive optics to correct for Earth's atmosphere, will rival and even surpass space-based observatories in certain tasks. For Andromeda, they will open new frontiers, revealing the lives of stars at its edges, the motions of its dwarfs, and the scars of past collisions written faintly across its halo. The history of observing Andromeda is, in truth, the history of our ambition. Each generation built larger mirrors, crafted sharper instruments, and reached farther into the night sky. Each believed it was approaching the limits of knowledge, only to discover that the horizon kept expanding. Andromeda, sitting quietly above us, has been both a constant presence and a constant challenge, daring us to see more, measure better, and think bigger. And so, the galaxy is not just a subject of study. It is also a partner in our story of discovery. It has grown with us, not in itself, but in what it represents, a mirror of our expanding awareness. From a blur in ancient skies to the centerpiece of cosmic revelation, Andromeda charts not only its own history but ours, reminding us that the universe is always larger than we imagine. If the disk of Andromeda is a sprawling metropolis of stars, then its star clusters are the neighborhoods that reveal the galaxy's character. These dense gatherings, some ancient, some newborn, hold clues to its past and glimpses of its future. They are the laboratories where stars are born, live, and die in accelerated harmony, offering astronomers windows into processes that otherwise unfold too slowly to witness. Among the most striking are the globular clusters, mesospheres of tightly packed stars that orbit Andromeda like satellites. Some contain hundreds of thousands of suns bound together in gravitational harmony. They are among the oldest structures in the galaxy, fossils from a time when Andromeda itself was young. Observing them is like opening a time capsule. Their stars, low in heavy elements, preserve the conditions of the early universe. Andromeda boasts more than 400 such clusters, more than twice the number found in the Milky Way. Each is a beacon of stability, enduring across billions of years, even as the galaxy around them shifts and evolves. Younger clusters paint a different picture. In Andromeda's spiral arms, especially along dense lanes of gas and dust, lie vibrant open clusters, gatherings of stars only tens or hundreds of millions of years old. These stars, often brilliant blue giants, live fast and die young, burning through their fuel in cosmic flashes. Their presence reveals where Andromeda's stellar nurseries are active, where cold clouds have collapsed into bursts of creation. As they age, these clusters disperse, their stars scattering into the wider galactic disk, becoming part of the anonymous stellar sea. But stars are not alone. Around them orbit planets, and given Andromeda's vast population of stars, the numbers are staggering. If even a fraction of its stars host planetary systems, there could be billions of worlds scattered across the galaxy. Rocky planets like Earth, gas giants like Jupiter, icy realms like Neptune, all are likely present, shaped by the same physical processes that govern planetary formation here at home. We cannot yet detect them directly, but statistical reasoning drawn from exoplanet discoveries in our Milky Way makes the conclusion inescapable. Andromeda must be rich with worlds. Some of those planets may orbit within their stars' habitable zones, the regions where liquid water could exist. If life requires water, carbon, and time, then Andromeda provides a nearly infinite canvas. Among its trillion suns, how many host living worlds? How many skies are lit by unfamiliar constellations? How many oceans cradle alien biochemistries? How many civilizations may have risen and fallen without ever crossing the gulf to reach us? These questions hang in the air, tantalizing but unanswerable, reminders of both the promise and the limits of our science. Clusters themselves may influence the fates of planetary systems. In the crowded cores of globular clusters, stars pass near one another, their gravities disturbing the orbits of planets, sometimes ejecting them into interstellar space. Such rogue planets may wander through Andromeda's halo, frozen and silent, forever unbound. In looser clusters, planetary systems may survive intact, nurtured by stability, their worlds evolving quietly for billions of years. Thus, even within Andromeda, the environment shapes the possibilities of life and survival. The search for exoplanets in Andromeda is still in its infancy. Our telescopes are not yet sensitive enough to detect the faint dimming of a star 2 million light-years away as a planet crosses its face. Yet the future holds promise. Next-generation observatories may one day resolve such tiny variations or detect the subtle wobbles of stars tugged by unseen companions. If so, the first confirmed exoplanet in Andromeda will not only be a scientific milestone, but a philosophical one, proof that even across galaxies, worlds are common. Consider the scale of this possibility. If Andromeda holds 1 trillion stars, and if even 1 in 10 has planets, that means hundreds of billions of worlds. If 1 in 100 of those lies in a habitable zone, we speak of billions of potential Earths. And if life arises readily where conditions allow, then Andromeda may be teeming with ecosystems, alien forests, alien seas, alien skies. To imagine this is to step beyond science into wonder, but it is a wonder grounded in probability, a logical extension of what we have already learned about our own galaxy. Star clusters, planetary systems, and exoplanets are not just features of Andromeda. They are its pulse, its living heart. They remind us that galaxies are not abstractions of gas and stars, but homes for worlds, cradles of possibility, canvases upon which the universe paints in infinite variation. Each cluster is a chapter, each planet a story, each potential biosphere a question. And though we cannot yet read them, their presence deepens the awe with which we regard our cosmic neighbor. Between the stars of Andromeda lies not emptiness, but a living medium, a delicate weave of gas, dust, magnetic fields, and cosmic rays. This interstellar medium, though tenuous compared to stars, is the raw material from which galaxies renew themselves. It is the hidden reservoir that feeds stellar nurseries, the canvas upon which explosions of death and creation are painted. The bulk of this medium is hydrogen, both in its neutral and ionized forms. Vast clouds stretch across the spiral arms, some cold and dark, others heated and glowing. In the densest knots of molecular hydrogen, gravity begins its slow work, drawing matter inward until stars are born. These molecular clouds are immense, often spanning hundreds of light years, and within them lie stellar nurseries where clusters of suns ignite in waves. From afar, they are invisible, but at infrared wavelengths, telescopes reveal their intricate structures, webs of filaments, knots, and voids sculpted by turbulence and magnetic fields. Dust, though only a small fraction of the interstellar medium, plays an outsized role. These tiny grains of carbon, silicates, and metals absorb and scatter starlight, dimming and reddening the stars behind them. Seen from Earth, they trace dark lanes across Andromeda's luminous disk, particularly along its spiral arms. They are not mere obscurers but catalysts, providing surfaces for chemical reactions and helping gas clouds cool enough to collapse. In every grain lies the potential for planets, for the solid worlds that will orbit new stars. The interstellar medium is not static. It is stirred constantly by what we might call galactic weather. Supernovae explode, carving bubbles of hot, ionized gas that expand through their surroundings. Stellar winds from massive young stars blow cavities, sculpting their birth clouds into arcs and pillars. These forces compress nearby regions, triggering new waves of star formation, while also dispersing material, preventing collapse in other places. It is a cycle of feedback. Stars create the conditions for future stars even as they destroy their birthplaces. Andromeda's interstellar medium also holds the signatures of past collisions. Streams of gas arc through its outskirts, remnants of galaxies it has consumed. Some of these streams are enriched with heavy elements, evidence that they once belonged to stars before being torn apart. Others are pristine, reservoirs of hydrogen still waiting to collapse. Together, they tell a story of accretion and assimilation, of Andromeda feeding upon smaller neighbors and incorporating their substance into its own. Astronomers map this medium across wavelengths, radio telescopes trace the 21-centimeter emission of neutral hydrogen, revealing the skeleton of Andromeda's disk. Infrared observatories highlight dust glowing faintly as it absorbs starlight. X-ray detectors pick up hot gas, heated to millions of degrees by violent events. Each view shows a different layer of the galaxy's breath, from the coldest clouds where stars are born to the hottest plasma where they meet their end. Together they form a portrait of a galaxy alive, restless, and constantly reshaping itself. The balance of gas and stars determines Andromeda's future. With its vast reservoir of hydrogen, it still has the fuel for generations of star formation. Yet compared to younger galaxies, its rate of creation is modest. Starbursts flare here and there, often triggered by interactions with companions, but overall the galaxy has entered a more measured phase. In time, as gas is consumed or expelled, Andromeda will grow quieter, its stellar birth rate fading. The interstellar medium, once rich, will thin, and the galaxy will settle into a slower rhythm of aging stars. But for now, the cycle continues. Clouds collapse, stars ignite, winds and supernovae reshape the medium, and new clouds form. It is a self-sustaining rhythm, an ecology of creation and destruction that maintains the galaxy's vitality. To watch Andromeda's interstellar medium is to watch the heartbeat of the galaxy itself, a pulse measured not in seconds but in millions of years. And hidden within this medium may lie the seeds of worlds. Dust grains that cool and fragment into denser clumps can give rise to planetary systems. The same carbon and silicates that obscure starlight may one day form rocky crusts beneath alien skies. Every star that forms is a chance for planets, and every planet is a chance for something more. The interstellar medium is thus not only a physical environment, but a reservoir of potential. For stars, for planets, perhaps even for life. To us, the faint blur of Andromeda is a distant shape in the night, but within that blur, the interstellar medium stirs, restless and alive. It is the unseen sea in which stars swim, the womb from which they emerge, the graveyard to which they return. It is the breath of the galaxy, invisible, essential, and eternal. Galaxies are not static monuments, but living systems, and within them, every star follows a path written by its mass. In Andromeda, where 1 trillion suns burn at once, this diversity of stellar fates is magnified into a cosmic symphony of beginnings, transformations, and endings. To imagine the future of Andromeda is to imagine billions of individual journeys, each unfolding on scales that dwarf human history. The smallest stars, the red dwarfs, dominate Andromeda's population. They are dim, cool, and extraordinarily long-lived, some expected to shine for trillions of years. These stars sip their hydrogen slowly, conserving fuel with remarkable efficiency. Long after blue giants have erupted into supernovae, and even after our own sun has faded, Andromeda's red dwarfs will still glow, tiny embers scattered through the dark. They are the true immortals of the galaxy, ensuring that light will persist far into the future. More massive stars live brief, dramatic lives. Blue giants blaze with furious intensity, burning through their fuel in only a few million years. Their deaths are spectacular. Supernovae that outshine the galaxy itself, scattering heavy elements into the interstellar medium and leaving behind neutron stars or black holes. Each explosion is both an end and a beginning, enriching the galaxy with the raw material for new generations of stars and planets. In Andromeda, thousands of such events occur every million years, shaping its evolution with violence and renewal. Stars like our sun chart a quieter course. They shine for billions of years, fusing hydrogen into helium until their cores contract and ignite new layers of fusion. When their fuel wanes, they swell into red giants, shedding outer layers into colorful planetary nebulae. The core collapses into a white dwarf, a stellar remnant that glows with fading heat. In Andromeda's disk, countless such stories are playing out now, invisible to the naked eye, but written in the spectra of its stars. Each white dwarf is a monument to endurance, a final ember persisting long after the blaze has ended. Over billions of years, these individual fates accumulate into galactic change. Andromeda's star formation will slow as its reservoirs of gas thin. The spiral arms, now bright with blue stars, will fade as fewer massive suns are born. The galaxy will redden, its population dominated by older, cooler stars. The fireworks of stellar birth and death will quiet, and Andromeda will begin to resemble the massive elliptical galaxies we see in older regions of the universe. This transition is not imminent, but it is inevitable, the natural arc of galactic life. Compounding this fate is the looming merger with the Milky Way. When the two galaxies collide, tidal forces will stir Andromeda's gas, triggering bursts of star formation. For a few 100 million years, the galaxy will blaze with new light, a renaissance of creation fed by the chaos of collision. But the outburst will be temporary. The merger will consume much of the available gas, and the combined galaxy, Milkomeda, will eventually settle into a quiescent state. With little fuel left, star formation will dwindle, and the galaxy will age into quiet grandeur. Even after star formation ceases, Andromeda's stars will continue their individual journeys. Red dwarfs will linger the longest, gradually fading into faint, cold remnants called black dwarfs. White dwarfs will cool until they, too, radiate no heat. Neutron stars and black holes will persist, silent relics of violence long past. The galaxy will not vanish, but it will grow darker, its brilliance dimming as the fires of fusion go out one by one. On timescales longer still, gravity will sculpt even these remnants. Stars and remnants will be ejected from the galaxy through close encounters or drawn toward its center, where a supermassive black hole will quietly accumulate mass. Over trillions of years, the galaxy will thin, its light spread faintly across space. In the far future, Andromeda's name may mean nothing, its structure erased, its stars scattered, its identity merged into the slow entropy of the universe. Yet even in contemplating this fading, there is wonder. For the story of Andromeda is not only about its eventual silence, but about the countless acts of brilliance along the way. Supernovae will seed new elements, neutron stars will pulse with precise regularity, black holes will sculpt space-time itself. Andromeda is both fleeting and eternal, fragile in its structure, yet enduring in its parts. Its fate is a reminder that all things change, that even galaxies grow old, and that beauty is found as much in endings as in beginnings. To gaze upon Andromeda is to confront a paradox. On one hand, it is just a faint blur in the night sky, easily overlooked, requiring no effort to see. On the other, it is the most massive object visible to the naked eye. 1 trillion stars bound together across 220,000 light-years, moving inexorably toward us. How can something so vast appear so delicate? How can an empire of suns seem so fragile, so easily missed between brighter constellations? The answer lies not in the galaxy itself, but in our perspective, and that perspective is the heart of its lesson. Andromeda teaches us about scale. Human beings live on a world 8,000 miles across, orbiting a star 1 million miles wide, within a galaxy of hundreds of billions of such stars. And yet even that galaxy is but one of trillions. To look at Andromeda is to see, directly with the human eye, a truth that words cannot capture. That we are small, not in the sense of insignificance, but in the sense of context. We are one note in a symphony so vast that it will play on whether we are here to listen or not. This realization can be humbling, but it can also be liberating, freeing us from the illusion that the universe revolves around us. It also teaches us about impermanence. Nothing in the cosmos endures unchanged. Stars burn their fuel, galaxies collide, and even light itself stretches with the expansion of space. Andromeda, majestic and serene, is itself a transient form. In 4 billion years, it will no longer exist as it does now. Its spiral arms will unravel, its identity merge with our own galaxy, and a new shape will emerge. To recognize this impermanence is to see that change is not an exception, but the rule, woven into the very structure of reality. And yet, within that impermanence, there is continuity. The atoms in our bodies, carbon, oxygen, iron, were forged in the same kinds of stars that populate Andromeda. The light we see from that galaxy began its journey before our species even existed. Yet it still arrives, unbroken, across the gulf. Change and persistence coexist, each giving the other meaning. To know that nothing lasts forever is not despair. It is a call to appreciate the fleeting brilliance of what does exist here and now. Andromeda also challenges us with the idea of connection. We are not isolated. Our galaxy and Andromeda are bound in a gravitational embrace, moving toward merger. The same laws of physics that shape its stars shape ours. The same elements forged in its supernovae exist in our blood and bones. In a profound sense, we are already part of Andromeda, just as it is part of us. Two expressions of the same cosmic order, linked by forces larger than imagination. To see the galaxy in the sky is to see kinship at a scale that defies language. There is also a lesson in perspective. For millennia, humans saw Andromeda as a myth, a cloud, a mystery. Only in the last century did we learn its true scale. What other truths lie just beyond the limits of our perception, waiting for better tools, sharper minds, or greater patience to uncover? Andromeda reminds us that ignorance is not failure, but opportunity. The universe is not a closed book. It is an endless text, and each discovery is only a paragraph in a story that will never be finished. And perhaps the greatest lesson is awe. Not the awe of fear, but of wonder. The recognition that we inhabit a universe vast beyond comprehension, yet intimate enough to be seen with our eyes. Awe that photons can travel for millions of years to fall upon a retina. Awe that life, fragile and brief, can rise on a small planet and ask questions about galaxies. Awe that we can look up at night and glimpse not only where we are, but where we are going, into a future written in the slow, patient motion of stars. So when we speak of Andromeda, we are not merely describing a galaxy, we are describing a mirror. It reflects our limitations and our potential, our smallness and our significance, our mortality and our continuity. It tells us that we belong to a universe larger than ourselves, that we are woven into a fabric of time and space that stretches beyond imagination. And in that recognition lies not despair, but belonging, the quiet certainty that to exist here and now is already to be part of something eternal. At the end of this journey, Andromeda stands before us not just as a galaxy, but as a story of light, time, and gravity written across billions of years. It is the story of 1 trillion stars bound in spiral arms, of clusters that preserve the memory of the early universe, of dark matter halos that stretch invisibly beyond sight. It is the story of collisions of streams of stars torn from smaller galaxies, of a future merger with our own. And it is, in the deepest sense, the story of us, for in its light we see both our origins and our destiny. From myth to measurement, from blur to revelation, Andromeda has been a constant companion in our sky. Ancient peoples wove it into legends. Early astronomers sketched its faint glow. Modern science revealed its scale, showing us that the universe was not one galaxy, but many. At each step, Andromeda expanded our imagination, forcing us to reconsider what we thought we knew. It has always been more than a patch of light. It has been a doorway, opening onto a universe of unimaginable scope. We have traced its chemical evolution, its cycles of star birth and death, its clusters and clouds, its dwarfs and streams. We have followed its interstellar medium, its supernovae, its black holes, and its gravitational web. We have glimpsed its role within the local group, its partnership with the Milky Way, and the collision yet to come. In every facet, Andromeda is both unique and universal. Unique in its nearness and detail, universal in representing the processes that shape galaxies everywhere. Andromeda's legacy is not only scientific, but philosophical. It humbles us with its scale, reminding us that our lives unfold within a cosmos too vast to measure. It teaches us impermanence, showing that even galaxies evolve, fade, and transform. It connects us, reminding us that the same elements forged in its stars course through our bodies, and it inspires us, calling forth wonder and awe that transcend equations and data. To look at Andromeda is to feel both small and infinite, both fleeting and eternal. Its destiny is already written in the slow currents of gravity. In 4 billion years, it will meet the Milky Way, and together, they will become something new. Andromeda, a single massive galaxy blazing with renewed creation before settling into quiet majesty. Long after humanity is gone, long after Earth is dust, this union will unfold, indifferent to us, yet part of the same cosmic order that gave us life. To know this is not to diminish our place, but to situate it. We are brief witnesses to a story far older and far longer than ourselves. And so, when we lift our eyes to that faint smear of light in the constellation of Andromeda, we are not just observing a galaxy, we are participating in a dialogue with the universe. We are listening to a story told in photons that have traveled for millions of years to reach us. We are glimpsing the past, imagining the future, and recognizing that we, too, are chapters in this vast book of existence. Andromeda is not separate from us. It is kin, neighbor, partner, and destiny. A reminder that the universe is not out there, but also here, within us, written into the very atoms of our being. It is a galaxy stretching over 220,000 light-years, a trillion suns woven into spirals of light, with worlds uncounted and mysteries buried deep within its dark matter halo. We have drifted along its sweeping arms, crossed its rivers of dust and gas, and paused within its stellar nurseries where new suns are born. We have stood at its blazing center, where a supermassive black hole holds court, binding the galaxy together with unseen force. We have traced the scars of ancient collisions, the shredded streams of stars, the faint glow of its dwarfs, and the filaments that tie it to the greater architecture of the cosmic web. In Andromeda, we found not just a neighbor, but a counterpart, a mirror to our Milky Way, and a vision of the union yet to come. And above all, we found perspective. To know Andromeda is to measure distance in millions of light years and time in billions, yet still to feel the connection that crosses the gulf. It is to remember that even within such vastness, we belong, as fragments of stardust, as children of galaxies, as participants in a story written across the sky. So as you close your eyes and drift into rest, carry with you the wonder of being alive in a universe so immense and luminous. Treasure the gift of awareness that lets us see beyond ourselves, and may your dreams tonight be filled with galaxies,